All right, hello, Algebra 2 students. This video is just going to go over some summary of factoring, which was section 4.4 in the book. And I just put this up as a guide. So this is something you might want to jot down and use it as you go through these questions. So the first thing always to look for is a GCF. So like no matter how many terms there are, right? Terms are parts. You might have 3 terms, you might have 2 terms. Always look for GCF. So like something like 2x squared minus 50, for example, look to see, hey, they're both divisible by 2, so you want to pull that out, pull that to the front, okay? And then where you go from there is generally going to be these different situations. The first two have 3 terms, okay? And you're going to factor those into little binomials. And the difference is the first one is fast factoring because of the x squared. You can just do x and x and then figure out what multiplies to the n number and adds to the middle. In this case, 3 and 4. Okay, and then if it doesn't start with x squared, you've got to do long factor, right? Which starts by doing 3 times negative 10 and then goes from there. So if you can't factor out the 3 using the GCF from part 1, then you have to do long factoring here if it's not a 1x squared. And we'll review that at some point in this video. And the last case is a square thing minus a square thing, which is what I actually have here. After we pull out the 2, then it's square minus square, which factors to basically the square root, and you add them together and subtract them. So here we're going to have x minus 5 and x plus 5. So you're going to two little factors. X and x makes the x squared, and then to get negative 25, you use positive and negative 5. And the reason this works is it's sort of like you have 0 x's in the middle, right? And that would match what we have down here because that's a minus 5x. And if we were foiling on the outer two, we'd get a 5x, and then those would cancel out, giving us the 0x in the middle. Okay, and then we'd still have the x squared and the negative 25 if we were foiling. All right, anyway, so I'm just going to throw some up at you, and I would kind of use this as your guide, right? And I would encourage you to pause the video and try each one before watching the solution. Okay, so this is the one where we've got 3 terms starting with x squared. So we're going to make a couple little binomials, use x and x here. And then they got to multiply up to 66 and add up to negative 17. All right, so in that case, it must be negative and negative because that'll multiply to positive 66 and add up to negative 17. So I would just make a list like 1 and 66 and then use my calculator like this 2 divided evenly. That works. Okay, but I'm still not at negative 17, so let's try the next one. I think 3 works, 3 and 22, but that'd be negative 25, not negative 17. 4 I don't think works, 5 doesn't work, 6 works with 11. And that is the pair we want, because if you make both of those negative, then they add up to negative 17. So that's our factorization. Okay, number 2. Again, pause the video, give it a shot. Okay, so this one is the square minus square case. So basically, we're going to make 2 little factors, and to make x squared, we're going to do x and x. And then to make negative 16, we do negative 4 and positive 4. And again, that works because it makes 0x in the middle. Okay, again, pause the video, give this one a shot. Okay, trinomial, there's no GCF. Should be looking for that first on every question. But because of the x squared, we're just going to do x and x. And then the other two numbers have to multiply to the 35 and add up to the 12. Right? And if you're having a hard time, again, I just do 1 divides it, 2 doesn't, 3 doesn't, 4 doesn't, 5 does, 5 and 7, and then 6 doesn't work, and so then that's it. Those are the only factors. So we want to use the pair that'll add up to 12. So positive 5, positive 7. Okay, again, pause the video, give it a shot. First thing I look for here is a GCF, but there isn't one, right? There's nothing common to 4 and 9. And then this one, hopefully I would realize that 4 and 9 are both my perfect squares, right? They're from the square list. So if I factor it, I'm going to use 1 plus and 1 minus, and then sort of do the square roots, right? This is the square minus square case. So to make 4x squared, we need 2x and 2x, and then to make minus 9, we need positive 3 and negative 3, right? So that would be our factors for this. And this is weird. This little binomial actually becomes binomial times binomial. If you FOILed these out, you would be back right there. All right. Go ahead, pause the video, give this a shot. So I think our gut reaction here might be to do like long factor, do 3 times 12 to get 36, which you can do that, but you actually don't have to, right? This would still work, I think. 6 and 6 would give you 12, but we can actually avoid all that mess if we just realize that they have a GCF of 3. Okay, and so I'm going to pull that 3 to the front and then divide everything by 3. Okay, and now we're good because now this is 1x squared. So our answer will have a 3, and then we can try to factor this trinomial here, those 3 parts, by doing x and x, and then multiply to 4 and add to 4. And since it's all positive, it's kind of nice, but I think the pair that works is 2 and 2. So this one factors to x plus 2 times x plus 2 with a times 3 in front. And again, if you multiplied all those together, that would give you what we started with, right? But we're doing the reverse. We're factoring, which means break it all apart. Okay, so there's our answer on 5. All right, pause it, give it a shot. All right, so the trick here is to realize that these have a GCF again, right? So I always would start there, and here we do have a common factor of 4, and they both have at least one x, so I'm going to bring that to the front. Okay, and so what I'm left with is take out the 4, take out an x, a minus symbol, and then divide by 4, take out an x, so we get 7, right? And so that is our factorization. That's it. There's nothing, this doesn't factor any further, so we're kind of done, other than it looks kind of sloppy and it bothers me, so I'm going to clean it up a little bit. All right, number 7. Pause the video, give it a shot. All right, so the first thing is here, I would look for a GCF, but there's nothing that evenly divides all of them. 2 doesn't divide 17, so we're kind of stuck. All right, so we can't do our little quick factor with x and x because of this 2. Okay, so we're going to have to do our long factor method. All right, so that long method, you go 2 times 30 to get 60, and then find a pair of numbers that'll add up to the 17. So again, I'm just going to make a list. 1 and 60, 2 and 30, 3 and 20, 4 and 15, still no dice here, and then 5 and 12. Oh, that one adds up to 17. Okay, so it's positive 60 and it's a positive in the middle, so we just need 2 positive numbers, so positive 5, positive 12. Okay, so next step, we're going to pull that apart. So it doesn't matter which one you pick first here, so I'll just do 5x plus 12x. Okay, and then we're going to bring down the other parts, so it's 2x squared and 30. Sorry for the bad handwriting there. Okay, now we're going to group and pull out GCF. So we're going to group the first 2, group the back 2, and pull out the GCF. So from the front, there's no number there, but we can take out an x. Right, they both at least have an x, so take out one of the x's. And then in the back, they're divisible by 2 and 3, but we actually want to use the highest number possible. So in this case, we would take out a 6, right? And if we divide these by 6, we'd have 2x plus 5. Okay, now we know it's happy fun times because these match. Okay, and so our factors are going to be the parts that match, which are 2x plus 5. that are underlined. And then the other factor is whatever in front. So it's just, in this case, x plus 6. Right? So we broke this thing into two binomials multiplied together using our long factor method. Okay, again, pause the video. All right, GCF is the key here. They both have an x. So I'm just going to pull that to the front. Okay, and then I'm going to see, can I factor this any further? But looks like no. So that's just a basic GCF factor, and we're done. All right, pause the video. Okay, same style, right? There's just two terms, and they do have a GCF. So I'm going to start with pulling out both 5 and x. So I'm going to have 5x in the front, and then what remains, divide by 5, take out x. Divide by 5, take out x. Okay, and then I could see if this factors anymore. It looks like square minus square, but there's no square here, so we would be done at this point. That's all the further we can factor. 5x times x minus 4. We reverse the distributive property. All right, pause, give it a shot. Okay, this looks like another GCF one. I don't know why I put so many in a row, but anyways, we can pull out a 4 and an x, and that would leave us with a 2x and plus 1. And I think that's it. This doesn't factor any further, so boom, we're done. Okay, again, give it a shot before continuing. All right, so again, this might look like we have to do long factor, but we can avoid it because of a GCF of 2. Okay, so I don't have to do this long factor because I can get rid of the 2 by just pulling it to the front. So that would leave us with x squared minus 6x minus 7. All right, and now I'm going to see if I can factor. It won't always factor, but we can try to factor that part. So we'll have a 2 in front, and then the part that's underlined in black, if we just take, okay, it's going to be x and x for the x squared, and then multiply to the -7 and add to -6. So our only choices for -7 would be 1, -7, or -1, +7. And to make -6, that's the pair we want. So this part in black will be x plus 1 and x minus 7, right? And combined with the times 2, that's our full answer right there. And that's that whole thing split apart. All right, I get a little more to do on these, so I'm running out of time here, so I'm going to actually stop and make a second video. Thank you for watching.